So I'm skipping 4.1 right now because I'm not going to be here tomorrow, so I don't want the TOC to do this because this stuff gets a little funky. 4.1 is the introduction of the unit. It's the antiderivatives, so that's what he's going to do tomorrow. Okay, it's a little more straightforward. So I'm doing this fun stuff. Okay, sigma from I is equal to 1 to 4 of a constant 3. What does that mean? Well, it means you're doing this. 3 plus 3 plus 3 plus 3. 4 times. Okay? Which we know the answer would be, that's equivalent to 3 times 4, right? Yes? Okay. Now, so we can say the top term is your n. The bottom term, sometimes it's j, sometimes it's k. It doesn't matter what the variable is. And it always starts with 1. I is equal to 1. We're summing all the terms from I is equal to 1 to n. So in this case, it's 4 terms. If it's a constant, all you have to do, if you look at this, our constant here was 3. We just took that number and multiplied it by the n value. So the sum of that would just be NC. That's it. That's a formula. I will give you these formulas. In university, you won't get anything, as per usual. So the sum of the constant from I is equal to 1 to n is equal to NC. Just n times the constant. What if I said I is equal to 1 to 6 of the term I? So what that means is you start with I is equal to 1. You put I is equal to 1 in, right? Which is 1. And then because sigma means sum, then you put I is equal to 2 in. And then 3, and then 4, and then 5, and then 6. All the way up till you get to the top number. Now you can add all those up, okay? And you would get 21 if you added them all up. But have you ever heard of the mathematician Gauss? That would be a no. Dead silence. So there's a mathematician named Gauss, lived way, I think, 1700s, German. He is, if I said, who's the best mathematician, what would you say?
Gauss.
Mr. Baldwin, that is the perfect answer. Is very wrong, but it's still a good answer. Most people would say Einstein or Newton. Einstein was a physicist, not a mathematician. And Newton was, he's pretty smart, but he's a bit of a, Newton wasn't a nice guy, okay? Gauss is considered one of the best ever. If you look at his grad students, they went on to do crazy, awesome stuff in math. But Gauss, the story goes, when he was in grade, I don't know, 5, I don't know what grade, 4, doesn't matter. When he was a kid in school, his teacher, because he was bored in class, his teacher came up to him and said, add up all the numbers between 1 and 100, okay? Thinking it would take him a bunch of time. He'd actually go 1 plus 2 plus blah, 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 blah. He came back to him like a minute later with the answer. And what he did is he did this. He saw this pattern. If I take 1 and 6, what's 6 and 1?
7.
If I take 2 and 5, what's that?
7.
What's 3 plus 4?
7.
So what would be the shortcut? How many 7s do I have? You could just go 3 times 7, right? That 3 is this number divided by 2.
Dude, this is like a math legend.
So he came up with this formula. If you're summing all the terms from 1 to n of I, the formula is n times n plus 1 over 2. All right? This n over 2, so here, 6 divided by 2 is 3, right? N, 6, plus 1 is the 7. So what he figured out when he was, I don't know, 8, 12, whatever age he was, is that if you want to sum all the terms from whatever to whatever, this is the formula you use. Okay? So if I said sum all the terms from 1 to 50, what do you do? Yeah, use the formula. So 50 over 2 times 50 plus what? So it's 25 times 51, which is, I don't know what that is. 1275. That's it. That's all you have to do. Okay? So then people went on. Now there's two other formulas. I'm not going to go through. If you want to look up the proofs, you can. Go to YouTube, plug in how do you do this. Somebody will have a proof for you. But the other two ones, I'm going to give you all these formulas. If you're summing everything from 1 to n of I squared, it's n plus 1, 2n plus 1 over 6. Sorry? All of that over 6, yeah. If it's I squared, yes. Okay? And if it's I cubed, it is n squared over 4. So these are the formulas. We're going to use them later on. We might get to it today, but maybe not. Okay, so these formulas will be given to you in this class, most likely not in university. Okay. All right. So we're just going to practice using these a little bit. All right. So let's do the sum from I is equal to 1 to 10 over, I messed up. Sorry, that's over n squared. That's what it should have been. Okay. What's n? It's 10, right? N is the top term. Okay. So I'm going to put that in right away. It will turn into a limit. Yeah. Right now, it's not a limit. We're just solving this particular one. Now, when you're doing summation, you can pull constants into and out of a summation. All right. So the constant that I'm going to pull out of here is 1 over 10 squared, or 1 over 100. Why am I writing n? I plus 1. Sorry. There we go. Okay. Now, your job when you get a question like this is to make, once you pulled the constants out, is to make what's left to rewrite it using one of our 4 formulas. Okay? So we can break this up to 1 over 100. Sum of I is equal to 1 to 10 of I plus okay. So this is being multiplied by this, but because this is added, I can add each individual sum like this. Okay? You're going to have to be very careful with the way you write this. Okay?
What are we explaining?
Yeah, can you start from the beginning? I didn't notice anything.
where? Like here? What does the sum mean?
I just don't understand, like, how did you start writing this formula?
What formula? I don't know what formula you're
Like
pointing.
n plus 1 to n plus 1.
These are, somebody has proved these. These?
Yeah.
These are proofs. Like somebody has proved that this equals this. I'm not going to ask you to reproduce this. All right? You just have to know how to take this and rewrite it this way and then solve it. Okay? So, if I take this, it's being multiplied by 1 over 100, I can rewrite it as individual sigma notations. Okay? What is the sum from I is equal to 1 to 10 of I? So on your formulas, matches this one, right? So I take that bit and I go, okay, 1 over 100. This first bit becomes, what is it? N plus 1 over 2. What's my n value? 10. So it's 10 plus 1 all over 2. And that is essentially n plus 1 over 2. That's what that is. But n is just 10. You don't have to, I just put the yellow in there so you can see what formula I'm using. Plus, what's the sum from 1 to 10 of a constant? It's NC. It's this one right here, right? And our n value is 10, so it's going to be 10. I'll write the 1. So now we just solve it. That's going to be 10 times 11 over 2 plus 10. So that's going to be, it's 110, it's 55 plus 10. So 65 over 100, is that it?
Can you re-explain what like the sigma means? Like where the numbers?
It just
What's
means
the
you're
numbers?
adding up all the terms from this bottom term to this top term.
Okay.
So you plug in I is equal to 1. So instead of doing this, you could do this. You could go put in I is equal to 1, right? So it's going to be 1 plus 1. That's okay. 2. Then you put in I is equal to 2. So plus 3. Then you put in I is equal to 3 plus 4. Then you put 5 plus 6 plus 7. You keep going all the way up to that point. That's all it means.
And the formula we're trying to solve, like the equation on the side of it.
I'm trying to, what is the value of this? I.e., what is, if I plug in I is equal to 1 all the way up to 10, what number do I get?
Okay. And when you have the brackets, you just split them up into their own.
Yeah, because if you're adding them, I can just do individual sigmas. I can add this one, and then I can do a sigma for that one. That's all I did there.
So like
Thanks.
No, not like
Yeah. All right. All right, let's do another one. What do we? Let's start with. Okay. The sum from I is equal to 3 to 9 of I squared plus 1. All right. What does your first term always have to start with? The lower bound, I, the lower one, the one on the bottom. It should always be what? Look at all the formulas. It always has to be 1. This one is not 1. So if it's not 1, what you do is you rewrite this. You go, okay, well, that will be the same as if I add all the ones from 1 to 9 of this formula, and then subtract the first 2. I is equal to 1 to 2 of the formula. This number has to be 1, but it's not in our case. So I make it 1, and I just go, okay, I'm going to add all the ones from 1 to 9, but then I'm going to take off the first 2 numbers, which is what this is. I is equal to 1 to 2.
Where did that come from?
I just made it up. I have to put that in. You have to put it in because, like, think of it if you do this. If you're going,
Yeah, why is it 2 on the top?
because you're taking off the first 2 numbers that you're adding. I can't do 1 to 9 there because then it would be the same thing, right? It'd be 0. So it's like if I said, here's all the numbers you're adding together. 2 plus 3 plus 4 plus 5 plus 6, say. But I only want to add these 3, 4, 5, 6, right? Okay. Basically, you can add all of them and then take off the 2 and the 3. That's what we're doing, the first 2 terms. Okay? That's why we did this, because our I value always has to start at 1. Okay? So if this was like a 5, and we're adding them from 5 to 9, I would do 1 to 9, and then I would subtract off 1 to 4.
Oh,
Right? 1 less. Does that make sense?
yeah.
All right. I know this stuff's kind of weird, but we're just going to have to fight through it. All right. So now I look at the first one. Sorry? You're going to separate them into separate sigmas. So we're going to separate it into I is equal to 1 to 9 of I squared plus sigma I is equal to 1 to 9 of 1 minus, whenever you are subtracting, please put brackets around it. Okay? And then we go I is equal to 1 to 2 of I squared plus I is equal to 1 to 2 of 1. Now this is it looks weird as we go through because the notation is a bit different. We're not used to this notation really. So it looks weird, but all the same algebra rules apply. Okay? You just have to be very careful when we do this. All right? Because this is going to lead into something that's going to take like a page to do. All right? And you've got to be very very careful. What?
I don't understand what's happening.
Well, we're not there yet. So let's just wait. Okay. Once you get to this point, you ask yourself, is there a sigma for I squared? What is it? n plus 1, 2n plus 1 over 6, right? So we go, okay, this turns into n plus 1. What was it? 2n plus 1 over 6 plus, what's the sigma for 1? NC, right? I'm going to write the n's and then we'll fill them all in afterwards, okay? Minus the one for I squared. I'm going to do it in a different color. I'm going to do it in blue, is going to be n plus 1, 2n plus 1 over 6 plus n c. Okay? So this bit is all this stuff.
Are they the same ends?
No, because that's why I'm...
So would you like
You could put the n in right away, because for this part here, this white stuff, it's 9. And then for the blue, it's actually 2, right? These are your n's. So, and you're going to see this is going to turn into a limit, because we're going to do n goes to infinity. That's what we're going to do. All right, so for the first two, the n value is 9. So I just plug in 9 plus 1, 2 times 9 plus 1 over 6 plus 9, and our c value is 1. I'll write that in. Minus. Now our n value is 2 for this bit. So it's 2 plus 1, 2 times 2 plus 1 over 6 plus 2 times 1. And now we got to do the math. That's 10. 9 times 10. 18 times 19 over 6 plus 9. 3, 6. Sorry? What are you asking me? Okay. 10 times 19 is 190 times 9 over 6. I have 285. I'm just guessing. 190 times 9 divided by 6. 285. Plus 9 minus 5 minus 2. All right, you plug all that in, you're going to get 287. Is that right? Is that what people got? Yes? Okay. I'm going to do one more example, and you're all going to groan, but I think it's actually easier. Are we okay? I know you're not okay, but here we go. Just don't freak out yet.
Is that a C? Or is that an I?
That's an I.
Okay,
Sorry.
okay.
Yeah.
That scared me, but-
Sorry. It's an I.
Is that a-
I know. There's a lot of stuff going on here.
Wait, these are basic?
No, that well.
Yeah, it is.
No, it's not the. I don't want to say it's the easy. These are tricky because you're not used to the notation. That's why. All right. It's a lot. We don't have to worry too much about the limit until the end. Okay. So this is what we're building up to this and a couple other things. Okay, so we have the limit as n goes to infinity of the sum of I is equal to 1 to n of 3I over n times 3 over n. Okay, the first thing you want to do is you want to get constants out of the sigma. Okay, so now you have to ask yourself, what is a constant here? 3 is a constant, or 9, right? So I can pull a 9 out. Is there anything else that's a constant? N is a constant. N is a constant, right? N is whatever this number is.
Yeah.
So it doesn't change. So I'm going to pull out a 9 over n squared. Does that make sense to everybody?
Yes.
Okay. So that's what we're doing. Pulling out a 9 over n squared. And we're left with the sum of I is equal to 1 to n of I. So it got a little simpler. Okay? All right. Now, the sum of I is equal to 1 to n of I. What is the summation formula for I? Yeah, n times n plus 1 over 2. All right? So, and this whole thing, I'm going to write it in yellow, turns into n plus 1 over 2. So I get that. Yeah? Okay.
So you just replaced I
With this, is that formula
is this sort of like
there?
an identity?
Sorry?
Is it like sort of like an identity?
It's exactly like that. Yeah. All right. Okay. So I'm here. Now let's clean this up a little bit. All right. So I'm going to multiply out the numerator here and here and just get n squared plus n over 2. Okay. And then I'm going to multiply the 9 over n squared in. Okay. So that's going to give me this. 9n squared over 2n squared plus 9n over 2n squared. Does everybody understand what I just did? I went to 9, went to both. Boom, boom. And the n squared went to the denominator, but because it's a single denominator, I'm going to break it up. I just broke it up into single things like this. Yeah, I'm going to simplify it in a sec here. Yeah, you can, that's, yeah. When you get good at this, I'm showing why you can do it. Okay. All right. Now we can simplify. What happens to the n squareds in the first one? Here. They go away. What about this one? 1 goes away. So then you end up with the limit. End up with that, right? Okay. What happens when you put infinity into this?
9 over 2.
Plus 9 over infinity. Any constant divided by infinity is?
0.
So what's the answer? That's your answer. Okay. So let's quickly go over this. When you get a question, first thing, pull constants out. Okay? You want to make what's in the sigma match one of your formulas. You only have 4 of them. You have, if it's a constant in there, if it's I squared, or if it's I cubed. You want to make it look like one of those. If it's I plus 1 or I squared plus 1 or whatever, break it into separate sigmas. All right, that's what we did. Here, I broke it into separate sigmas. Okay? Then, when you do that, you use your formulas to convert the sigma notation into, I'll just call it n notation. Okay? For everything. And then plug in your n's. Solve. Just be careful, because sometimes, especially if you're subtracting, the n's will be different. All right? And then if it's going to infinity, if it's a limit as n goes to infinity, I know that looks like a gong show at the beginning, but it actually is a bit, I would say, easier. And when you get to this part down here, like right here, you should be able to see that that end is going to cancel that, and then this end is going to go to 0, essentially. Okay, we've done a bit of that kind of stuff. All right. I know this is tricky notation. You just have to practice it because I don't want to show you what the questions are going to look like, but it's a page of this. Okay, because we're going to have to adapt it to different functions. Because what we're going to lead up to is figuring out the area under curves using this stuff. Okay. It leads into integrals, yeah. Yeah. Sorry? Like, yeah, it should be that. You're right. But it's still going to get infinity in the denominator. So yeah, you're right. Okay. Your questions are page 263, numbers 13 to 23 and 37 to 41, please. Please do these because the only way to get good at them is to practice. I get that